Okay, good afternoon, everyone. My name is Brian Sims. I'm with the University of Texas at Arlington. First, I'd like to thank you for inviting me to come over and visit your facilities today. I appreciate that very much. Look forward to visiting with you. We're going to have a very informal class this afternoon, so feel free to stop me if you have any questions at any point in time, and we'll go over those questions and help to educate you a little bit more about asbestos and asbestos-containing materials. First, let me start by asking how many folks in this class, or how many folks here have seen this class before? Goodness. All right. I've got a lot to live up to. We're going to do better than last time then. Okay, what we're going to do today is we're going to go over what asbestos is, where it comes from, a little bit about the health effects associated with long-term exposure to asbestos and asbestos-containing materials, a little bit about the rules and regulations that are in place, federal and state rules in place for the management of asbestos-containing materials in buildings. And then we're going to talk a little bit about policies and procedures that should be in place in any facility such as your own. Let me first start by asking, somebody tell me what asbestos is. Class interaction here. What is asbestos? A mineral. It's a rock. Okay. It's a mineral, but it's a very unique mineral, one of the most unique minerals on the earth. It has four very unique characteristics to that particular mineral. Can anybody tell me what those characteristics might be? What makes asbestos unique? Come on, help me out.
It's always break in the same shape.
Okay. First, let's start with its strength. It's very strong. It's one of the strongest rocks on the earth, much stronger than granite, much stronger than quartz, dolomite, gypsum, the other minerals that we find on our earth. Because of that, we used it in things such as floor tile, VCT, VAT. Does anybody know what those terms are? What is VAT? Vinyl asbestos tile. It has asbestos in it. What is VCT? Vinyl composition tile. What's the difference between the two? One has asbestos, the other has quartz and other silicates in it. VCT, the new 12 by 12 VCT tiles we put down, they'll last 10, 15, 20 years maybe. The old 9 by 9 VAT tiles that you see in schools, they last 30 or 40 years before they wear down, simply because this rock's harder than this rock. Asbestos is a much harder mineral than quartz or the other silicates that are in VCTs today, limestone specifically. So it's a very strong mineral. Let's talk about the second characteristic that makes it unique. Make any guesses?
Heat resistance?
There you go. Thermal resistance. Heat and cold. It's a very thermal resistant rock. Basically, this rock doesn't get hot. It doesn't get cold very easily. That's because of how the chemicals that are used to compose that rock or make that rock in the earth and how it's made in the earth. It takes temperatures in excess of 2,000 degrees Fahrenheit before you start affecting the rock, that particular mineral and the composition of that mineral. Because of that, we used it for two applications in construction. We used it to hold heat in and to hold heat out. What would be an application where we'd want to hold heat in? Insulation, pipe insulation, boilers, be a good example. Boilers and steam lines. We want to hold that intense heat onto a boiler or a steam line, so we wrap it with material that basically doesn't get hot very easily. What would be an application where we want to hold heat out?
Refrigeration.
Okay, we'll talk about brake pads in a minute. What was the other one?
Refrigeration.
Refrigeration could be possible, but one I'm looking for is fireproofing. I was looking for fireproofing. An application where we want to hold heat out. So let's talk about fireproofing a little bit, because this is really what brought asbestos into the United States and blew it into a multi-million-dollar industry. Back at the turn of the last century, we started building buildings in the United States, mainly in the Northeast and the West Coast, that were superstructures. Okay, high-rise buildings, 100 floors plus. If you're familiar with what a high-rise building is, basically it's a steel superstructure. It's H-beams, I-beams, bolted together, welded together. Put a masonry or glass facade on the exterior, put mechanical, electrical, plumbing systems, interior finish out, and you've got a building. We all know it's a little more complicated than that, but in a nutshell, it's a big piece of steel with some lightweight concrete poured in place and some kind of facade on it. As we started building those buildings, typically, especially in the United States, maybe not in some other countries, we always put a way to get out of that building in the event of an emergency or a fire. We put stairs. There's elevators that carry people up and through the building for convenience, but there's always stairs that come through that building to get people out. Let's say that we get a fire on the 30th floor of this building, right there. What occurs when you get a fire and you put a fire on metal? Is anybody familiar with the use of a cutting torch? How many people use cutting torches? Okay, what's the first thing that happens to that metal before it lights? What's it do? It turns a specific color. Turns red. What happens when metal turns red?
It's real soft.
That's how we bend metal. Okay, that's we take the strength, the tensile strength of that metal away by heating it. Same thing occurs when you put a fire on a H-beam or an I-beam in a building. You let it burn for a few minutes. Now there's 70 floors. Let's see if I can use a different pen here. There's 70 floors of steel and concrete on top of that 30th floor fire. What do you think is going to happen when that metal gets hot? It loses its tensile strength, you lose the structure of the building, and it collapses on top of itself. It comes down, it crushes the building. What's that? World Trade Center is a very good example of that. That actually occurred in a building back at the turn of the last century. So what Congress went back to the construction industry and said, if you're going to build 100-floor buildings, you need to find a way to protect them from fire. Fire was the big issue at hand at that point in time. So what they did is they went back in and industry just started building these buildings again, and as they did, they would build that same steel superstructure, and they would spray before they poured any of that lightweight concrete in place. They had a big piece of steel there. They would spray the entire building with asbestos, coat it with about a 1/4 inch to a 1/2 inch coat, a spray applied fireproofing. So now they would cover the entire building with it. We get a fire on that 30th floor, and that fire is burning right here. There's plenty of time for people to get out of that building before that steel superstructure starts to heat up, because it's coated now with a fireproofing material that needs temperatures in excess of 2,000 degrees to really start affecting that too much. So that was very effective, worked very well, and many, many buildings in our country had spray-applied fireproofing throughout the buildings. Any questions over its thermal resistance? Very important aspect of asbestos. Okay, the third characteristic, and Paul, you touched on it just a few minutes ago, one of the applications for it. Asbestos is very friction resistant. Much like its strength, basically this rock doesn't wear down very easy. For that reason, we used it in things like brake shoes, clutch assemblies of heavy equipment cars. Still using brake shoes and clutch assemblies across the country, across the world today, especially in heavy equipment. If we put asbestos in brake shoes of your cars, they last 30,000 miles. We put quartz in the brake shoes of your cars, they'll last 5,000 miles. This rock's simply harder than this rock. So because of that, it's friction resistant. We used in a lot of assemblies, brake assemblies and clutch assemblies. Also, somebody touched on it a few minutes ago about space travel and air travel. Asbestos is used for, or is still used today as mastics and glues on wings of all kinds of aircraft, and especially aircraft associated with out of the atmosphere. NASA uses it extensively. Okay, any questions over these characteristics of asbestos? Strong, thermal resistance, friction resistant. Okay, now let's talk about the other. Somebody hit on that a few minutes ago, shape. That's the issue. The morphology or the shape of this rock makes it very, very unique. Let's talk about rocks for a few minutes. Asbestos is one of the few rocks on the earth that is considered fibrous. And to be fibrous, it has to meet the definition of at least 3 times longer than its width. And not exactly, at least 3 times longer than its width. So that marker is fibrous by definition. That eraser would be fibrous by definition. There's 6 types of asbestos on the earth. 5 of them look like that, and 1 of them looks like that. Let's talk about these 5 first. These 5 asbestos forms, asbestos is found all over the earth, but there are, like any mineral or heavy metal, there are larger deposits in certain areas of the earth of that particular metal or heavy or mineral. Predominantly, these are amphiboles or needle-like fibers. Are predominantly found in South Africa. They are found in the United States also. Montana has a huge deposit of tremolite. But for the most part, they're found in South Africa. And they were mined from South Africa, for the most part, brought to the United States and all over the world. This particular fibrous rock or asbestos form is chrysotile, and it's predominant to the northern United States and Canada. One of the largest mine on the earth is in Quebec, Canada, and it is a chrysotile mine. So for the most part, this is homegrown. This is from overseas. That being said, we used a lot more of the homegrown fibers because it was less expensive to get them here, ship them here, than it would be these. So the vast majority of the asbestos you'll find in buildings today in the United States are going to be chrysotile asbestos. Now you're going to find these others, amosite and chrysotolite and anthophyllite. You'll find some of these in building materials. They're not uncommon. You'll see them fairly often, but not anything like the quantities of chrysotile that you'll see in the United States. If you were in South Africa, it'd be the opposite. You'd see a lot of these amphiboles. Okay, any questions over the shape of this rock? Now let's take it a little bit farther. Talk about why that might be a problem for us. Basically, there's 3 types, or for the most part, there's many different types of rocks and on the earth, and minerals on the earth. For the most part, you can throw them into about 3 different categories. You have rocks that would be granular in shape, round for the most part, and that would be something like, let's take quartz as a good example. Then you'll have materials that are plate-like, micas, and gypsum would be a good example. Those are rocks that like peel apart in a plate. They'll come apart with plate-like. And then you have fibrous, such as asbestos. So those are 3 very unique different shapes of minerals. Okay, let's talk about why that can be a problem for us. Okay, how many folks remember the 3 diseases associated with asbestos exposure? Anybody remember one? Asbestosis, that's good. Mesothelioma, lung cancer, and lung cancer. Let's talk about the 3 real quick. And actually, asbestosis is not a disease. It's a scarring in the lung tissue, but it's classified as a disease when it comes to asbestos exposure. Let's visit about that real quick. Now, I'm not a good artist, so you guys don't make fun of me. That's a set of lungs. Here's your windpipe. You breathe in, and you inhale, and then, of course, when you exhale, you breathe air out. Talking about asbestosis, asbestosis is truly a dose-response. There's a dose-response relationship to asbestosis. The more dose you put in your body, the higher chance of a response you're going to get. So it's about large quantities entering into your lungs. 2 ways to be exposed to asbestos. You got to breathe it or eat it. Inhalation or ingestion. It won't come through your eyes, won't come through your ears, won't come through your skin. You have to breathe it or eat it. And those are two pathways. We're not worried about you eating building materials, typically. I've got a few folks on my campus that might, but it's inhalation that's the issue that we're concerned about. When we breathe in construction, we breathe a lot of different materials in. We breathe fiberglass, mineral wool, synthetic fibers, dacron, rayon from carpets, cellulose fibers. We breathe in pollens and molds and things of that nature into our body. When we talk about asbestos, I'm going to run a scenario real quick for you where we're going to cut a hole in the wall. Okay, we're going to cut a hole, 3.0 door in that, 3.070 over here, 3.070 over here, through drywall. Okay, what's our means of cutting a hole in drywall? How do we do it? Pop a line and break out what? What's your tool? Sawzall, reciprocal saw. What happens when you hit drywall with sawzall? Snows in your face immediately as soon as you hit it, it's snowing. Now let's say in that process we're going to breathe, let's say this wall does not contain asbestos. Okay, what is drywall made out of? Gypsum. So we got gypsum over here. We know what that looks like. It's a little mica, plate-like material. We're going to breathe 80,000 gypsum particles. Okay? 80,000 particles come into our lungs. We breathe those particles. What are they going to do? bounce around. When you exhale, they're going to come out. Okay, the vast majority of those particles are going to come out of your lungs. You're not going to like it. You're going to cough. You're going to feel like bad things are going to happening to you, but you're okay. They're going to come out for the most part. Normal set of lungs, by the way. Okay, now let's cut a hole in this wall over here. Same thing, but this time we've got 5% cryostyle asbestos texture. Okay? We break out the Sawzall, it's snowing in our face. Now what are we breathing? What do you think they're going to do? They're going to act like 80,000 little darts, 80,000 little harpoons, and they're going to stick. Not all of them. Maybe 274 stick out of 80,000. Okay, why do they stick in the lungs? Simply their shape. Best analogy I can give you is a dartboard. You put a dartboard on the wall, you throw a baseball at it, it bounces off. You throw a dart at it, it sticks. It's simply the shape of the mineral you're putting in your lungs, and that's all there is to it. Asbestos is not toxic. It is simply a mineral that is shaped uniquely in a fashion to where it can stick in your body pretty easily when you breathe it in. Now what happens is when it cuts you, or when it goes in your body and sticks, it cuts you. You don't feel it. These are microscopic fibers. When it cuts you, it creates scar tissue. When you get cut on the exterior of your body, you get a scar. When you get cut on the interior of your body, you get a scar. That scar tissue over a long period of time is not as elastic as your regular skin is. So as you start to breathe, what happens over a long period of time of exposure, you're 20 years old, your lungs are about like this when you breathe in and out. After 10 years of asbestos exposure, long-term, heavy dosages, you create scar tissue and your lungs don't stretch as much. So they're about like this. After 20 years, your lungs are about like this. They're barely moving because you've created so much scar tissue inside of your body. That's what asbestosis is. It's a scarring of the lung tissue created from mass quantities of asbestos cutting the interior of your lungs. This is not something that I would expect to see from a construction worker. This is not something I would expect to see from the general public walking into a building. The folks that had this particular problem either worked in the mining of asbestos or the milling of asbestos, where they took big rocks, threw them in crushers, stood over them 8 hours a day, 5 days a week, no respiratory protection, and breathed that while it snowed in their face, asbestos rocks and minerals. The minerals that we're talking about in size here are roughly 5 microns. A micron is a millionth of a meter. A meter's 39 inches long. So break that into a million times real quick for me. It's humanly impossible. You can't see it. Tiny, tiny fibers that create these kind of problems. The latency period for asbestosis is 20 years. So basically from the time of heavy exposure to the time that you have symptoms, you're around a 20-year period of time. Mass quantities of exposure. Any questions over asbestosis? Okay, we're good there? Let's move on to lung cancer, mesothelioma, and we'll get out of health effects here in a few minutes. Okay. Asbestosis, lung cancer and mesothelioma are basically cancer. The only difference in between the two is lung cancer is interior of the lung, cancer inside the lung itself. Mesothelioma is a cancer of the pleural lining of the lung, the mesothelia are the exterior lining of the lung. In both cases, basically, the fiber is entered into the lung, and then at that point in time, either penetrates the exterior walls of the lung and works itself into the body, or it stays within the lung and the air sac and creates cancer in that particular area. Talk about that real briefly. That's a human cell. That's an asbestos fiber, roughly somewhat proportionate. Basically, that fiber has been inhaled into the lungs. It's penetrated that human cell. It's killed that human cell. When that human cell dies, it still has, the body recognizes that there's a foreign object in the body. And the body has defense systems to fight foreign objects, regardless of what they are. That could be bacteria, that could be a virus, that could be any group of minerals or entities that enter into the body that's not supposed to be there. So what happens, when that cell dies, there's a little impulse that goes up there and says, I died, by the way, there's a foreign object in my body, in our body. So the brain sends macrophages, what are called macrophages, to destroy that foreign object, to eat it basically. That's what they do. They're garbage disposal. They eat everything that's in your body that's not supposed to be in your body. The problem with these macrophages is that they cannot destroy this particular foreign object because it's a mineral, it's a rock. They can't eat rocks. Well, they don't quit and go home when they figure out that they can't eat them. They continue to try to digest that until they die. And they keep coming, and the brain keeps sending them, and over a period of time, this becomes a growth of a foreign object over a dead cell with a bunch of macrophages. We all know the term for that? Cancer. Okay? Foreign object in the body, not supposed to be there, body cannot destroy it. The unique thing about asbestos, one of the unique things, asbestos is considered a carcinogen. A carcinogen is a cancer-causing agent. A cancer-causing agent in this particular instance is something that we internally cannot destroy, our body cannot destroy. Therefore, we create cancer within our bodies because we can't get this out. Now, this rock's not hurting anything inside our bodies. You could have 500,000 rocks in your body, you're going to weigh a little bit more, but they're not going to hurt you at 5 microns in size unless they're being attacked and creating these kind of problems with growths and macrophages. Okay, any questions over that at all? Any questions over lung cancer? This is lung cancer in itself, where the cells inside the lung, take it outside, put it in the mesothelia, the mesothelium, and it becomes mesothelioma.
At what point does that tumor become able to spread?
A lot of things can occur here, and let's talk about that a little bit. Let's talk about how we take care of that problem. How was cancer addressed 50 years ago, 40 years ago?
Radiation.
Before radiation treatment, what do we do?
Cut it out.
Cut it out. You go in and you cut the tumor out. You get the tumor out of the body, okay, physically remove it. Well, that works real good, except I missed a little bit. I missed that little spot right there when I was a surgeon and taking that tumor out. Come out of recession, impulse back to the brain, still something in the body. Whole growth period starts over again. That's potentially coming out of recession and into full-blown cancer again. You had to get it off. And that's one of the problems with that. I think I know there's many research institutions today that are working on that right there. They want to break the chain. Break the link to the brain so that this all stops and this growth period stops here. Now there's radiation treatment where you can blow this thing all to pieces and see where you can send it to and hopefully have it removed from the body through body fluids, regular body fluids that you may have. But it's very difficult when you start spreading that all over the body and addressing it, because this can get picked up, carried into the bloodstream and moved over here into the left leg, moved up here into the brain, different places in the body. So it's a very difficult medical problem to address. But we all know that there's many bright minds that are working on that today. Let's talk about the latency period of lung cancer. Lung cancer has a 30-year latency period. From the time of exposure, typical, now these are periods that are averages. Time of exposure to the time you have a symptom, 30 years. Mesothelioma, 40 years. That's a long time, okay? And that comes into play in the regulations here in a minute when we talk about those here shortly. Any questions over the health effects, the 3 diseases associated with asbestos exposure? Yes, sir.
Would you say mesothelioma was?
The latency period?
Yeah, no, was that the outer?
Yes, that's the outer, the mesothelium, the pleural lining of the lung, the exterior lining of the lung. That's where the fiber has made its way through the lung tissue and out into the body cavity. Okay, any questions over that? Let's move on and talk about cigarettes real quick and the problems that are faced with that.
Nothing less because the fibers can break down small enough to just pass right through the wall, right?
Yes, yes. They can move right through the wall. You'll never know that they're migrating like that. They can migrate to different parts of the body. All right, cigarette smoke. Let's visit about that briefly. Plastered all over the exterior. How many people smoke? Anybody in this room smokes? All right, wow, that's impressive. That means there's some probably fibbing, but that's okay. Plastered all over the exterior of your cigarettes are folks that smoke cigarettes, or warnings that say, cancer-causing agent, carcinogen, may cause cancer, do not smoke if you're pregnant. Asbestos or cigarettes also can create those same types of problems with tars and inside the lungs developed onto cells that create issues where macrophages cannot destroy them. There's very little medical difference in how cigarettes and cigarette smoke affect the interior of your lungs than asbestos does. Because of that, cigarettes are also considered carcinogens. Let's talk about why you don't want to mix the two of them. I'm going to make somebody with a really long neck here. Forgive my drawing again. Inside your throat, there are thousands of little hairs. Does anybody remember the name? Cilia. What do? Wave, 24/7. That's what they do. They do this. They're a filtering system that creates, they're not a static filter, they're constantly moving, catching particulate matter. They're your coughing mechanism. Okay? When they're affected or touched or bothered, and something goes back up here to the brain and says cough. So you're going to cough at that point in time. That's the reason why when you're in a dusty environment, high particulate matter, you're going to cough more because you're breathing these particulates and they're coming through and they're bumping these hairs and they're going down into your lungs. Very effective, your coughing mechanism is a very effective defense system that you have in your body. When you smoke, cigarette smoke temporarily paralyzes these cilia. May take you 2 cigarettes, may take you 5, may take you a pack, but they're going to eventually lay down and go to sleep during that process of smoking. So what you do effectively in smoking is remove that particular defense system from your body. Okay, you paralyze that defense system, which means that we can expect to receive a lot more particulates in our lungs. So now not only are we dumping the tar and the carcinogens from the cigarettes into our lungs, we're dumping other particulates that may be caught during that process into our lungs, i.e. asbestos and other bad things we wouldn't want in our lungs. Fortunately, they temporarily go to sleep. When you stop smoking, they start coming back to life. Everyone's different, everyone's body chemistry is different. A unique scenario that I like to discuss is smoker's cough. Is anyone familiar with the term smoker's cough? Let's walk through that through a day. We're a smoker, we get up in the morning, 8 o'clock in the morning, we fire up a cigarette. By 10 o'clock, we put our cilia asleep. 10:30, we're deep in construction. We're busting down walls. We're going through, popping out ceiling tile. We're breathing all these things. These cilia, for the most part, are gone. They're asleep. 10 o'clock at night, we go to bed. Hopefully, we put the cigarette out. 2 in the morning, 3 in the morning, cilia start coming back to life. What are they doing? They're firing off impulses. They just woke up. They don't know what happened. They've been asleep. So they're telling the brain, cough. Do what you're supposed to do, cough. So the smoker wakes up, it's 5 in the morning, cough, 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 cough. What's the one thing that makes a smoker quit coughing? Cigarette. Put them back to sleep at 8 o'clock. You're good to go. Back out the door again. It's the reason why you do not want to mix the two, in that you wipe out a defense system, and then there's other synergistic occurrences that occur in the lungs when you mix tars and when you mix those tars and asbestos fibers. Okay, any questions over health effects? Okay. Let's move on and discuss a little bit more about asbestos, about what it might be in. Okay. Asbestos was predominantly used in the United States from around 1920 to about 1980. The heyday for asbestos, a decade right there, the 60s. Okay? Most of the asbestos put in the United States was installed in that decade in the 1960s. So you get into a building in the 1960s, take it to the bank, it's there somewhere. You get in a house built in the 1960s, it's probably there, residential. Let's talk, it's easier for me to tell you what's not asbestos, suspect asbestos, and what is. There are basically 4 safe building materials never manufactured to contain asbestos, okay? Never manufactured to contain asbestos. Let's see if we can guess what they are. Let's start, think broad. Broad building materials used every day in construction.
Steel.
Okay. I have my own order, there's no particular order. I just remember them better in my order, so that's number 2. Wood, that's number 1. Two more. One of them is relatively new to the industry, 20, 30 years. Plastics. One more. I put plaster, that's not right. Plastic. Okay, plastic. No, I classify stones and bricks and concrete in masonry. And the only reason why they're not in here, concrete does not contain asbestos, by the way. But back in here and around in here, there were some masonry products that did contain asbestos. Yeah, there were some fire bricks used in boiler applications that contained asbestos. There were a lot of cementatious material, boiler doors. Actually, there were some concrete mixed grouts and things of that nature that contained asbestos back in the 20s and 30s, all the way up into the 40s. So because of that, masonry is not in this group.
What about glass?
That's the last one, glass. Wood, metal, plastic, and glass. Basically, these materials were never manufactured to contain asbestos. Now, there are a lot of other materials that do not contain asbestos. But what I'm looking for are materials that were never manufactured to do that. Now, there's a caveat to this, and it happens to be with wood. And you need to remember this one, it's very important. Although wood was not manufactured to contain asbestos, it has been used to enclose or encase asbestos a lot of times. If I'm in a building and it's a 6th floor building and I'm on the 6th floor at the stairwell, what's that door? What kind of door is that at the stairwell of the 6th floor building?
Fire door.
It's a fire door. Okay? If I'm standing at a fire door, and let's say it's a wood door, that fire door most likely, especially if it's built in the 1960s, what it's going to be is an 1.5 inch thick block of about 65% cryostyle asbestos, a little wiggly one. Around the exterior of that, it's going to have some hardwood to hold on the hardware, hinges and door hardware. And then it's going to have about an 1/8 inch laminate of wood over that to protect it, encase it, and make it decorative. And when that fire burns up to that 1/8 inch laminate of wood, it's going to take it off like that. But it's going to hit that block of asbestos and stop. And it's going to burn up against that block of 65% cryostyle. Okay, so in this case, wood is not manufactured to contain asbestos, but it was used to encase it. So you have to remember the wood, metal, plastic, glass thing when you're dealing with things such as fire doors. Metal also is used to encase as jacket material around insulating materials. Anybody in facilities and physical plant would have seen that probably in the past. Plastics and glass do not contain asbestos. There are many other materials that do not contain asbestos, but for the most part, these are your safe ones. Any questions over that? Let's talk about the materials most likely. Yes, sir.
Did treated wood ever contain asbestos?
No. I'm not aware of any woods ever containing asbestos. And now treated wood does contain some other pretty nasty stuff, not asbestos. Materials most likely to contain asbestos, especially when you get into the 60s and 70s, textures, joint compounds, ceiling tiles, floor tiles, chalkboards, every kind of mastic and glue used, HVAC mastics, cove-based mastics. What's that?
Curtains.
Some curtains, yes. Curtains contained electrical wiring insulation, a lot of high-intensity lamps, theatrical stage lamps, things of that nature contain asbestos. There are woven asbestos material around those. Many different materials throughout construction have contained asbestos. Doesn't mean every ceiling tile has asbestos in the 1960s. They do not. Doesn't mean every floor tile. Doesn't mean every 9x9 floor tile has asbestos in it. It does not. Doesn't mean every 12 by 12 does not, because there are many 12 by 12 floor tiles with asbestos in them. So that's an area where a lot of folks get confused, that they'll think if a material is a 12 by 12 floor tile, it does not contain asbestos. That is false, very false. Okay, any questions over these timelines at all? Asbestos is used all over our country, all over our world. It's going to be in Walmarts. It's going to be in the church. It's going to be in your kid's school. It's going to be in your home. If your home was built in the 60s or the 70s, I guarantee you I can come find it. And where I'm going to find it, see if that's drywall. I'm going to find it right there. I'm going to find it in the joint compound. The vast majority of the joint compounds used in the United States in the 70s, 60s and 70s were asbestos containing. Not every one, but a very high quantity of joint compounds. And that's residential and commercial joint compounds. Okay, any questions over that at all? Okay, let's talk a little bit about the rules, the regulations pertaining to asbestos, what you can and cannot do. There are federal and state rules, regulations regarding asbestos containing materials in buildings and what you can and can't do, especially in the state of Texas. In our government, with environmental laws, the federal government will promulgate a rule or a law. And first a problem will come. A problem will come from society, general public, to the government. The government looks at that problem and says, okay, who is the proper body within our government to study this and come back with a determination. In this case, that occurred with asbestos in the 70s. It went to the Environmental Protection Agency. OSHA had it for a little while, and then it went on to the Environmental Protection Agency. The EPA looked at it, and the EPA said, okay, we think we've got a problem here. So they wrote, in 1986, they wrote AHERA, Asbestos Hazard Emergency Response Act. What AHERA did was wrote guidelines for K through 12 of all public schools in the United States. Okay, K through 12. Every public school in the United States covered immediately. What AHERA basically said is this: public schools, go find all your asbestos, assess the condition of it, remove it only if necessary to facilitate your day-to-day operations or renovations of that building. Didn't say go remove all your asbestos. First place, there wasn't enough money to remove all the asbestos. So what the schools across the nation started doing is just that: inspecting, finding it, is it in good condition, clean it up, keep it in good condition. Why do you think they picked K through 12? Anybody got any idea why they didn't just say everybody? Well, it started with money. It always does in our government. And so there had to be a rationale to that. And so you've got some forward-thinking folks, and I certainly applaud them. Let's say that, let's go back and look at the disease problem real quick. We've got asbestosis 20 years, we've got lung cancer 30 years, we've got mesothelioma for 40 years. Let's take an average. 30 years, lung cancer. That's our problem. Okay? Now let's take that 30-year lung cancer latency period and let's look at the general public. Let's look at construction first. What's the average age of a construction worker? Let's say it's around 30 years old. Okay? Plus a 30-year latency period for lung cancer, we've got a 60-year-old person with cancer. Let's take kids, K through 12. Average age there, say they're around 10. Plus 30-year lung cancer. It was unacceptable to have a bunch of 40-year-old people in the United States with cancer. It was more acceptable to have a bunch of 60-year-old people in the United States with cancer. If you're going to throw your money at something and you want the biggest effect, then you're going to look at what gets you there. And in this case, they didn't have enough money to regulate. They didn't think they could regulate effectively the entire country and all of the different construction industries and apartment complexes and all of those things. So what they did is they slowly enacted first AHERA in K through 12. And it was effective. It got it kicked off. Now today, virtually everyone's regulated. What the government allows for is for the states to take that regulation, an environmental regulation, and they can always write something more stringent, but they never can write something less stringent. So they either accept the federal law as it's written or write a new one and make it more stringent. Texas decided to write a new one and make it more stringent. Texas has one of the most stringent asbestos rules in the country. And what Texas did in 1992, they wrote TAPA, Texas Asbestos Protection Health Rules. What they did with that particular document is they took everything that O'Hara said and then they applied it to the general public. So now, Walmart's covered. Your church is covered. The schools are covered as they were under O'Hara. Any public place that the general public can walk into is covered under the Texas rules. And basically, if you take all of those rules in a nutshell, put them all into one, in one basic statement, they come out to say this. In the state of Texas, you cannot perform demolition, renovation, maintenance activities, installation activities, or any other activity that may affect a suspect asbestos-containing material, we'll talk about that in a minute, without first determining whether that material is asbestos-containing and having the proper engineering controls in place. In other words, being trained and licensed to deal with that material. A lot of key words in that statement. Suspect material, disturbing the material, being properly trained and licensed to do so. Let's talk about, break that down real quick and then we'll get you out of here. Suspect asbestos-containing material, as far as the rules are concerned, anything prior to 1980. That's the big date. Don't think there's not asbestos in buildings after 1980. There's plenty of them. I have buildings on my campus after 1980 with asbestos in them. There's not a lot. You don't see as many, but there are some. Mostly what you find is mastics, glues and mastics. So we're talking about buildings prior to 80 being constructed. If that's the case, then let's talk about a public building, what a public building is real quick. It's easier for me to tell you what's not covered than what is covered. Basically, what's not covered in the state of Texas is military installations. They're not covered. Now, there was an agreement, memorandum that was written by President Clinton, which included military installations to fall under the state regulations associated with, or the federal regulations associated with asbestos. Military installations, residential dwellings, 4 units and less. Okay, if it's greater than 4 units, it's covered. If it's apartment complex, it's covered under the rules. They have it. The same rules apply to them as they do you. The other area that's not covered are manufacturing areas that do not allow access to the general public due to a hazard. In other words, I'll give you a good example. There's a GM plant over in Arlington. Huge building, Bill Chevrolets, GMCs. All this in here, they build cars. It's very dangerous where you build cars. General public can't walk in there and watch them build cars. Not covered. Up here, though, they'll pull a car in and they'll put a brand new Pontiac or Buick or whatever it is they're wanting to sell right there in the showroom. General public can come in there. That part is covered under the rules. So basically, we're military installations, facilities in the industry that have a danger associated with it or a hazard in that particular area, and residential dwellings are not covered. Yes, sir?
And those 2 areas have to be separated by a wall made of a certain material in order for one to pass and one not?
No, they just have to be separated by a process that will not allow the general public to enter, a guard, something of that nature. Okay, so if you have a public building in the state of Texas, that means the Exxon station down the road is going to get tore down next week. That building falls under the rules. So whoever owns it, doesn't matter who owns it, you tear that building down, you have to have an asbestos survey. You got to inspect, find the material, and remove the material that you're going to disturb before that renovation project or maintenance project. Address that material. It doesn't mean you have to remove it all. If I'm coming in here, and that's not ceiling tile, bad example, if there was a land ceiling tile system in this room, and I'm coming in here and I've got to get in that corner and get to that speaker, I've got to pop one tile. Doesn't mean I have to come in here and remove all the asbestos out of this room before I go pop that tile. That means a trained and licensed person has to go pop that tile. And they've got to move that tile out of the way, clean it up, make sure that that works safe and that area is safe for that maintenance person to go above that ceiling. Key word, disturb. Okay, you've got to break the material as far as the regulations are concerned. Break the material, get it into the air to where it can be breathed. And that's the issue at hand. That's disturbance, the matrix of the material. One key word we'll end on this. One thing to remember, especially in the line of work that you're in, is the word friable. Who knows what friable is? Anybody know the definition? Friable can be that material can be crushed or pulverized by normal hand pressure to release that fiber into the air. Is a ceiling tile friable or non-friable? It's friable. I can break off a corner of it, I can do this, and I can crush it, get it in the air. Floor tile, friable or non-friable? It's non-friable. I can break it, but I cannot crush it and pulverize it with my hand to get that fiber in the air. Now, what can I do to a non-friable material to get it to release asbestos? Grind it, sand it, drill it, some kind of physical device or means of abrading that material. I can use a tool and get a non-friable material to release it. So that doesn't mean a non-friable material is not a problem for us. It just means that if there's floor tile in this room that's asbestos, I can walk on it, I can lay on it, I can do anything I really want to it, but I can't sand it, I can't grind it, I can't drill it without releasing fiber. Now, ceiling tiles, if they're asbestos containing, can you lift them? Think about that a minute. Now, I've lifted thousands in my years in this business. I have never lifted an asbestos or any ceiling tile that a little bit of white stuff hadn't fell down. Now, if that's an asbestos tile, what's in that little bit of white stuff? That's disturbance. You can't lift them. Joint compound, another good example. I don't want to mark up your wall, but that joint compound in its current condition, friable or non-friable? Non-friable. I cannot crush it or pulverize it with my hand. Now, what I can do is throw a belt sander on it. What happens if I throw a belt sander on it? Katie, bar the door, it's snowing. We all know that. So that would be a disturbance that would take a non-friable material and create a huge problem for you. So think in that mindset, can I disturb that material with my hands? If you can, then most likely it requires a trained and licensed person to do that in the state of Texas. Any questions over that at all?
What about residential?
Residential, if it's less than 4 units, does not fall under the regulations. All these other things still apply, though. The material's still there. It's still a health hazard. To the degree that you're going to expose yourself is probably minimal. Probably not, probably doesn't rise itself to a degree of concern. But you can take up materials out of your house and you can set them on the curb, and the trash service can come by and pick them up, and you're not breaking the rule at all. But you still have an exposure issue you need to give consideration to personally. I don't think it's good practice, but of course many folks do it. Yes?
But you got blow-in insulation. How is the average person going to know if that's asbestos in the house?
There is a huge mine that closed down in Libby, Montana. Closed in the 70s. One of the classic, most famous lawsuits, Graves, W.R. Grace was the manufacturer of that particular product. And that product was shipped all over the country and put into homes and used as blown-in insulation. It's called Zonalite, was the name of the product. I have seen very little of that in the state of Texas. For the most part, now you get up in Colorado, Montana, every house up there seems to have it blown in the ceilings. Huge problem, very friable, has tremolite, which is one of those amphiboles in it. Much more dangerous material than chrysotile, in my opinion anyway. But you see very little of that in the southern states because the need for that wasn't really what it is in the north where it's colder. Yes? What's that?
What's an employer's responsibility as far as protecting the employees?
Survey, find it. The very first thing you have to do is find it. And that's what we find, and I've traveled a lot and assisted a lot of different, especially higher education institutions, and the first thing that we find is they do not have good survey data. They don't know where it's at. Until you know where it's at, then it's hard to write policies and procedures that will protect yourself and your employees against it. Once you've identified the location of it, at that point, then put in good general work practices, which include a work permit system, not allowing maintenance personnel to go out into the field and affect a known asbestos-containing material without trained and licensed people being there. So the first key is go find it. And that typically needs to be done, well, that needs to be done in the state of Texas by a licensed inspector and laboratory doing those samples.
What's the employee's responsibility?
To, once educated in regards to the rules, to follow the rules. Basically, the disturbance issue. And that's the one I try to get across to the employees the most, is that you know what your job is. And if you can physically, use that word friable, if you can physically damage that material with your hands or the process you're about to do, unless you know it's not asbestos, then don't do it. You know, if you know it's not asbestos, then proceed, of course. We have folks at our campus that are trained and licensed asbestos folks. We've got 4 of them at UTA that do nothing but asbestos work, 40 hours a week plus. And they follow all our tradesmen around. They follow our carpenters, our plumbers, our electricians. And our electricians and all the trades folks basically have been educated to a point to where they understand that they can't touch that material without asking the question first. Yes, sir.
Once asbestos has been disturbed, how long is it airborne? How long is it still like dangerous to be?
There's many theories, many studies were done, but in general, from about your breathing zone, let's say 5-6 feet, person's breathing zone, to the time it hits the ground, could be as much as 24 hours. Microscopic fibers suspend for incredible lengths of time. Can be picked up by natural airflow, moved around a room. Just because the room's clean and looks good doesn't mean it's necessarily clean. Any other questions? I know that many of you, it's time to go home for many of you, and probably myself included. I live a long ways from here. Any other questions? Okay, I want to thank you all again for inviting me to come over this afternoon. Appreciate it.